Creating a two-story design in Google SketchUp is a great way to visualize architectural concepts. Here's a step-by-step guide to help you get started, even if you're relatively new to SketchUp. Step-by-step, two-story building design in SketchUp. Step 1. Set up your workspace. Open SketchUp and choose a template, preferably in architectural units like meters or feet. Save your file before starting. Step 2. Draw the ground floor plan. Use the rectangle tool to draw your building's base footprint. Use the push/pull tool to extrude the walls up to your desired ceiling height, e.g., 10 feet or 3 meters. Draw internal walls with the line or rectangle tool, then extrude them using push/pull. Add door and window openings using the rectangle tool and cut them out using push/pull. Step 3. Add the second floor. Draw a second rectangle directly above the first floor, aligned to the top of the walls. Use guides or construction lines if needed. Push/pull this floor slab to desired thickness, typically 0.3 to 0.5 meters or 1 foot. Build second-story walls just like the first floor. Use group or components to keep each floor separated for easy editing. Step 4. Add windows, doors, and stairs. Add windows and doors by cutting rectangles and using components from the 3D warehouse. For stairs, use the line and push/pull tool to model them manually, or search for a stair component in the 3D warehouse and import it. Step 5. Add roof and details. Use the line tool to draw the roof shape, gable, flat, hip, etc. Use push/pull or follow me tool to extrude the roof. Add details like railings, textures, furniture, and landscaping. Step 6. Apply materials and textures. Open the materials panel. Apply wood, brick, glass, paint, and more to surfaces. Customize colors and finish using the edit option. Step 7. Organize and clean the model. Group elements, e.g., each floor, roof. Use tags, layers, for better visibility control. Check with sections and scenes to create presentations. Tips. Use components for repeated elements, e.g., windows, doors. Save often and keep backups. Use SketchUp Pro or SketchUp for web depending on your access. A parapet wall is a low protective wall that extends above the edge of a roof, terrace, balcony, walkway, or other structure. Its primary purpose is to provide safety and protection, but it also serves aesthetic and functional roles depending on the context. Types of parapet walls. Plain parapet, a simple extension of the wall without any decorative elements, mainly used for safety. Perforated parapet contains decorative openings or patterns, offering both aesthetics and ventilation. Paneled parapet, designed with panels for decorative appeal. Embattled parapet, features a notched design, historically used in fortifications. Functions of a parapet wall. Safety, prevents people from falling off the edge of rooftops, terraces, or balconies. Protection, acts as a barrier against wind, rain, and debris. Fire safety, helps slow the spread of fire between adjacent buildings in some cases. Aesthetics, enhances the appearance of the building, especially when designed decoratively. Mechanical screening, can hide rooftop equipment like HVAC units from view. Construction materials. Parapet walls can be built using various materials depending on the building type and function, such as brick or block masonry, reinforced concrete, glass, for modern designs, steel or metal panels, in industrial or modern applications. Design considerations. Height, typically ranges from 1 to 1.2 meters, 3 to 4 feet, depending on building codes and intended use. Waterproofing, proper drainage and weatherproofing are essential to prevent water seepage and damage. Structural support, must be adequately reinforced to withstand wind loads and potential impacts. Common issues. Water leakage, Poor construction or lack of proper drainage can lead to seepage. Cracks, thermal expansion or foundation movement can cause cracks. Maintenance, regular inspection and repair are necessary to ensure longevity and safety. In summary, parapet walls are critical structural and design elements in both residential and commercial buildings. Their importance goes beyond safety, contributing to the architectural integrity and functional performance of the structure. Placing a parapet wall, process and considerations. A parapet wall is a low protective wall along the edge of a roof, terrace, balcony, or walkway. It serves both functional and aesthetic purposes, providing safety, supporting roof structures, and contributing to the architectural design of a building. Here's a detailed overview of placing a parapet wall. 1. Purpose of a parapet wall. Safety. Prevents people from accidentally falling off the roof or balcony. Protection. Shields the roof surface and drainage systems from wind and water damage. Aesthetics. Enhances the exterior appearance of a structure. Support. May serve as a base for fencing, lighting, solar panels, or other utilities. 2. Materials used. Brick. Common and economical for residential and low-rise buildings. Concrete. Durable and preferred for modern, commercial, or high-rise buildings. Steel/metal. Often used in combination with concrete for industrial applications. Glass or aluminum panels. Used for modern aesthetic appeal in commercial buildings. 3. Design considerations. Height. Typically ranges from 2.5 to 4 feet, 75 centimeters to 1.2 meters, depending on building type and local building codes. Thickness. Depends on material and structural requirements, usually 4.5 inch to 9, 115 millimeters to 230 millimeters, for brick. Drainage. Should include proper weep holes or scuppers to allow water to drain off the roof. Finishing. Parapets must be plastered or finished with coping stones or caps to prevent water seepage. 4. Construction steps. Marking and layout. Measure and mark the line of the parapet wall on the roof slab or terrace surface. Surface preparation. Clean and roughen the surface where the wall will be constructed to ensure proper bonding. Laying foundation/base. Place a concrete bed or starter course if required, especially on a waterproofing membrane. Wall construction. Lay bricks or blocks using mortar. Ensure vertical alignment and level at each course. Reinforcement. Steel bars. May be embedded depending on structural needs. Curing. Keep the wall moist for 7 to 10 days to ensure proper curing of the mortar. Finishing. Plastering on both sides for weather protection. Install coping stones or RCC caps with a drip course to prevent rainwater ingress. 5. Safety and compliance. Must comply with local building codes and regulations. Adequate anchoring and reinforcement are crucial for wind resistance in high-rise structures. For glass parapets, use laminated or tempered safety glass and certified fittings. 6. Maintenance tips. Regularly inspect for cracks or water seepage. Clean weep holes and drainage channels. Repaint or recoat as necessary to maintain waterproofing and appearance. Perforated parapet wall. A perforated parapet wall is a type of parapet wall that includes intentional openings or voids in its structure. These openings can be decorative or functional, depending on the design requirements and the intended use of the wall. Perforated parapet walls are commonly used in both residential and commercial buildings, especially in architectural designs that prioritize aesthetics, ventilation, or weight reduction. Key features of perforated parapet walls. Design aesthetics. Perforations can be arranged in various patterns, geometric, floral, abstract, to enhance the architectural appeal. Often used in modern and contemporary buildings to add visual interest to the rooftop edge or balcony walls. Ventilation and airflow. The perforations allow air to pass through, improving natural ventilation in roof spaces or terraces. This is particularly useful in hot climates where air circulation is necessary.